Welcome back. This is Chapter 7. Chapter 7 is all about internet, the web, and all that kind of good stuff. Okay. I want to go over just kind of the chapter objectives because they're kind of cool. So here's the things you're supposed to learn. Briefly describe how the internet works. Yeah, that'd be kind of, I'm not getting into terrible details and mechanics, but just generally speaking, how does the internet work? To include methods of connecting and the role of these internet service providers. Describe the World Wide Web. Explain the use of markup languages, browsers, that kind of stuff. Identify and briefly describe the process of creating software applications and web pages on the web. List and describe several sources of information. Yeah, that'd be kind of easy. Listen and describe several forms of online communication. Explain Web 2.0. We've used that term a lot. Explain how internets and extranets use internet and the internet technologies and how they're different. Okay, so that's our learning objectives. As always, I always like to concentrate on the why part. You know, why learn about this? And this should be fairly obvious that the types of technologies and the things that are available on the internet are just amazing. And you know, if you're a business major, you're going to have to kind of keep up in this space, so to speak. This is where everything is happening. So yeah, sorry, that's just something you're going to have to know. They talked about all these internet success stories and all these places where people are making tons and tons of money. And yeah, you need to know a little bit about that. Okay, so at the very beginning, they talk about, you know, the internet growth. And there's a figure down here that talks about, oh, I'm not going to do a stupid animation. In the book, on page 309, there's talks about a little pie chart that shows where all the internet users are in the world. In North America is about 11% of the internet use. Now, we kind of got it first, and you know, we're pretty saturated. That's a good term. You know, with all the people who really want internet service have internet service. So we're kind of sort of there. It's just that, you know, there's an awful lot of other places on the planet that have a heck of a lot more people than we do. So, because we kind of had it first, our growth is kind of slowed down. We had tremendous growth there for a short period of time because we were first. But, you know, whoever's first, you know, their growth is going to slow down and everybody else is going to catch up. So if you're looking at internet growth, you know, we're nowhere near the top. Some people estimate that about 40% of the people who are alive on the planet today have access to the internet. That's kind of an interesting thing to think about. They talk a little bit about the social responsibilities and internet censorship. That internet censorship rarely ever works, okay? And, you know, if you're some sort of a regime out there that, you know, doing terrible things to your people are going to find out, you know, in other countries, and they're going to have access. And, you know, being a bad guy is tough these days because people are going to find out. So, yes, the effects on politics are pretty straightforward. I mean, they talk about this example where they were getting ready to pass a law to increase censorship, and people went nuts. You know, had riots and all that kind of good stuff. A brief history of the internet. In a long time ago, you know, in 1969 or so, the Army got together, or defense folks, DARPA, got together and said, we want a fault-tolerant network that pretty much will allow us to send messages back and forth wherever we want. And it's going to be so that if, you know, a nuclear bomb, heaven forbid, you know, blows up, you know, whatever, some city in Seattle or some city, that it won't disrupt the communication network. The system will just automatically route around it. So the entire internet was kind of designed with a military mind of fault-tolerant. That was what they were thinking. And how to route traffic around missing nodes or perhaps slow nodes. Okay, that was how it's all supposed to work. Okay. The next section basically talks about what happens, you know, how does the internet work? Okay. Well, the internet basically is made up of the pieces that you can't see, okay, are these what they call backbones. And the backbone is, you know, probably like fiber optic cables that run from your largest metropolitan area, wherever you are, to the next city. And so cities across the U.S. are all tacked together with fiber optic cables. And the weird part about that is you don't actually end up paying directly for those backbones. I mean, you're paying your internet service provider, and your internet service provider is kind of sort of like leasing time on some of these cables. So they have to pay the guy who has the cable. But so I don't actually pay the fiber bill that connects Dallas to Cincinnati. Okay, I don't pay that directly, at least. Okay. Another interesting thing behind the backbones is it's not really a written law per se, but the communication tariff setups are so that the competing companies basically aren't allowed to, like, well, no, this is only for my traffic. I'm not going to route any of your traffic through my backbone. It's not like that. It's basically they have reciprocal agreements, and they say, well, look, you know, you're going to let some of my traffic go on your network, and I'm going to let some of your traffic come on my network, and we'll just look the other way kind of thing. So it's kind of an interesting business if you're in the backhaul business. Kind of weird. Okay, they talk in a little bit about how messages get routed. And so I'm on this machine over here, and I want to send a message to some other machine. Well, it has to bounce around. It goes to the edge router, because this is probably a local area net. An edge router, and it bounces around all sorts of places in the United States. It could bounce around 5 or 6 times until it finally ends up with another edge router, gateway router, that pops onto the LAN and goes to wherever machine it was supposed to go to. We are going to talk a tiny bit about protocols, not too much, but transmission control protocol. You've probably heard of TCP/IP. Well, the TCP part is the transmission control protocol. And basically it's used, and not to get into too much detail, but transmission control protocol is all about, I sent you something, did you get it? You know, it's that error checking and flow control and all that kind of good stuff. I sent you something, and it waits and says, let me know when you got it. Okay, good. I'll send you another one. Let me know when you got it. Okay, got it. Now I'm going to send you the 4th one and the 5th one. It's that traffic cop thing going on. The IP protocol is all about getting it from point A to point B. In other words, the path it has to take to be able to get to you is what IP is all about. And TCP is all about, okay, fine, now that you finally made it through that maze till you got to the other end, did it arrive intact, and did you hear it? That's what it's all about. So one is about flow control and error control and that kind of stuff, and the other is all about routing packets from one place to another. Okay. And we've probably all heard of things like IP address, and we'll go into that a little bit more. But the 64-bit number for an IP address is supposed to be unique, and until we ran out of numbers, and we had to come up with a whole new scheme called IP version 6, which has 128 bits. So that ought to last us a while. But we'll talk about that in just a moment. The next thing to talk about is a Uniform Resource Locator, a URL. Now that is the more technical term for a web address. A lot of people say a resource, a Uniform Resource Locator, URL, meaning a web page. And so typically URLs are, something like http:// blah, 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 blah. It's a protocol, and then a series of names that get mapped out to an IP address so they can find things. Now, HTTP is just one of the protocols that would classify as a URL. There's lots of others. It's not just HTTP, although that one is pretty doggone common. Okay, the next thing we're going to talk about really is the IP address thing. This gets a little complicated. The idea is that every machine on the web, I hate it when these things don't show up. Well, let me just talk then. Okay, every machine on the internet is supposed to have a unique number. And so we ran out of numbers quite some time ago. And so how does it all work? Well, in my household, I have several computers, but they all share a single outgoing IP address. In other words, instead of having it, let's just say I'm making this up. Let's say I had 6 computers. I don't, but who cares? If I had 6 computers, in theory, I should have 6 individual IP addresses. Okay, and that would be just fine, but I don't. I have one IP address that comes to my house, and then after it comes to my house, then I get another set of IP addresses that I can share inside my house. And the way it's done is through a thing called Network Address Translation, NAT. And NAT is all about providing me a temporary kind of IP address that is not unique. In other words, if I have an address inside my house, it's very likely that my neighbor across the street probably has the exact same IP address on his local area network. And that's perfectly okay, because that local number is only used inside my LAN, and as soon as it leaves my house, it immediately switches over to the real IP address, and the packets coming in, they switch back and forth. So he has one good IP address, I have one good IP address, and stuff on the inside, who cares? So that's how that all supposed to be. It converts my internal pool to a unique number that gets assigned to me. Okay. There was an interesting thing here. There was a cool countdown timer. I thought it was kind of cool. Back when we were running out of IP addresses, it had this little cool thing you could put like on your web page and showing when we're going to run out of IP addresses. These are by regions. There's a thing called like North American region, and it looks like right now Africa is the only one that actually has a few blocks of the old style IP addresses available. Everybody else is in the red. There's just no more blocks left. Okay, so we're to the point where we've exhausted all of our IP. It's called V4, IPv4 addresses. Okay, so back to where we were. Okay, so let's continue. There's a thing in here talking about those upper level domains. This is called a top level domain, and you've heard of these, .com, .edu, .gov, those kind of things. Well, there's a naming company, in our case, ICANN, and the North American thing that does this for us, the Internet Corporation of Assigned Names and Numbers. And you might think, well, why do we need an organization to do that? Well, I just told you that every one of these IP addresses has to be unique. So if they're going to be unique, is really only going to be one person you can go to get numbers. Otherwise, somebody's going to screw up and, accidentally assign a number that's going to be used twice. So we have these organizations that are set up that do this for a living. Okay, so top level domains are these guys. The lower level domains, so for example, if I had Microsoft.com, the top level domain is actually the one at the end of the address. It's kind of backwards. Instead of having them, it starts with the most specific and then gets bigger and bigger and bigger, and finally you get to com. Because there's there's 112 million hosts out there in .com. When you got down to Microsoft, there's probably, 5 or 6,000. And, it just kind of gets narrow and narrow and narrow when you go from right to left on an IP address. Okay. This figure, which doesn't show up, but it's in the book, talks on page 312. They talk about the different techniques that you can use to connect to the internet. Essentially is, let's say I have a LAN, like a corporate LAN, and I just have an edge router that connects to the internet, and I'm connected. I'm done. Now, hopefully they've got some sort of a firewall, so they're not just plugged directly in. That's one way of connecting to the internet. And unfortunately, this is a good place to stop for the 15-minute mark. And we'll pick this thing up again in just a few.